Last week, Kubernetes 1.29 dropped, so today I'm joined by Ben Hirschberg, CTO and co-founder of ARMO, to talk about some of the security implications of this release. Nice to see you again, Ben.
Hey Craig, I'm really happy to be here.
Tell me what's interesting and new about the idea of using user namespaces for containers, and what's changed recently in Kubernetes to support them.
So user namespaces are a really great way to separate the things that are happening inside the containers and things that are happening on the Kubernetes nodes. So you might already heard about namespaces, which is kind of thing on which the whole containerization technology relies on, and the separation of these different parts, different software that's running inside the computer. But user namespace is I would say late addition to the Linux kernel, which enables you more separation from what's happening inside the container and outside the container. And it enables you to give different user IDs and group IDs to the same process inside the container and outside of the container, which means that from a security perspective, you can have the process running inside the container running as root process, as process 0, which is kind of a bad thing, usually.
I think we were told not to do that.
Yeah. We are usually told not to use root. But for different reasons, the way the containerization technology evolved throughout times, most of the containers we are running inside Kubernetes are running as root. I don't know if you heard about that.
That's why we use Kubescape, to tell people they should not be doing that.
This is one of the reasons. Yeah, so it's a very bad practice, and actually, user namespaces are enabling us to separate better the containerized processes. And in 1.25, Kubernetes added the support to configure this feature to enable users to enjoy the underlying kernel technology to be enabled. And in the last release in 29, we got a very interesting addition to that, because since this new addition, different security gates can be relieved because you used to put protections around our cluster in order not to have root containers running inside, not to have privilege escalation enabled, and so on. And the pod security standards have prevented pods from starting, if it was configured to do that, was preventing pods to start when they had these fields enabled. Mm-hmm. Now, if you have the user namespace separation, then you don't really mind these kind of settings, right? Because this actually relieves this problem. So this is what was added last week to Kubernetes.
So if you have a container that says create user with a UID 1000, for example, you might have two different containers running on the same node, and it will appear to both of them that they have a user with UID 1000 or 0 if they want to run as root, but they will in fact map to different users on the node.
Yeah, that's true. This is how it works.
All right. So there's some new features in 129 that improve token management for service account security tokens. Can we start by talking a little bit about how service accounts work in Kubernetes and how tokens are allocated to them so that pods can do things on behalf of those accounts?
So the general idea in Kubernetes is that Kubernetes differentiates between different kinds of clients when authenticating them. So a difference between users and groups. You can associate users and groups with different roles through role bindings, which is like pretty standard. But the question is, how do you give authorizations to and privileges in the Kubernetes API to non-user kind of objects like microservices themselves? So this is where service account comes into the picture. Service accounts are I would say the pseudo users, the machine users of the Kubernetes API. all these service accounts are Kubernetes objects. They can be created, deleted, updated, and you can associate your pods and containers with service accounts. You can add different privileges, different roles to these service accounts, and the pod itself can use the service account in order to access the Kubernetes API. Now the question is how, because how the Kubernetes API knows that he's talking to a pod. Now the way to do this is through service account tokens. So Kubernetes creates this JWT token. It maps into the containers running inside the pod, and the containers can take this token from a very specific path inside the container and use them to authenticate against the Kubernetes API.
Right.
Now, obviously, this has different security reasons to manage this good, right? Because as an attacker, if I'm able to take a service account token out of the pod, I can use it, the same authentication credential, just as I would use your password to access Gmail. I can use it to authenticate and use the same privileges as you got. So there were a few things in the later releases that changed around this, because everyone understood that in Kubernetes, this has Kubernetes security, protecting the tokens are a paramount goal here, because an attacker can steal them and just do whatever he wants.
Is my token roughly equivalent to my password in this case?
Yeah. Roughly, yes. But in a different, it works in different dimensions. So one of the evolutions that came in is the lifetime of a token. So you wouldn't really like if we change your token like every hour, right? It wouldn't be like a very, very good thing. It would be really hard to follow. But the nice thing about these kind of things that here it can be changed. And one of the things that was evolved is actually the lifetime of a token. So even if an attacker is able to steal a token, the lifetime will be much more limited, where he can use that thing. The second improvement was that up until now, the JWT, which was mapped inside the pod, only contained the pod name for an authentication. Mm-hmm. Now what they did is actually limited it even more. They've added also the node name of the pod. So when the API server receives the request, it can also cross-check that the request is coming from the node it expects it from, and thus again limiting an attacker. If the attacker is able to steal the token, there's an additional check that the requests are coming from the right node. So there is a security improvement here.
So previously, if I was able to exfiltrate the security token from a pod, I might have been able to create another pod with that same name on a different node and then authenticate with that token.
Yeah, right. And for that, this was this is an improvement in general. Obviously, there is a long road, because sometimes for an attack you don't need a lot of time, because if an attacker is able to penetrate your pod, maybe from that pod he still can use the token, but again this adds an extra layer of protection already.
All right. There's been a lot of extra layers of protection around the software supply chain recently. One thing I noticed that's new in 129 is the ability to enforce image pull secrets. Tell me a little bit about the problem that we're solving here.
So you're right. The additions lately in the space of software supply chain, and really, I think in the last few releases we've seen an evolution. From a release, the new feature was added in this solution space. In the last release in 129, what we saw is the addition of validation of image pull secrets in the case when a container image is already inside a node. So what happened before is that, let's say you had two pods. The first pod is using image A, which is coming from a private registry,
Right.
and the first pod who started up needed to pull this image in order to run. So it took the credentials, authenticated itself against the registry, and was able to pull the image. The second pod, when it started, and it used this very same image as before, it simply took the same image from the local image repository and didn't need the registry to pull that image.
Because it was cached locally at that point.
Yeah, right. So, so the problem here was that obviously the second pod didn't went through the same authentication and authorization process against the container registry. And this opened up us for different problems, obviously, for injection stealing images, private images, especially in shared environments. When you have like multi-tenancy inside the cluster and the same node is shared by different groups, different companies even, and one company could create a pod which pulled an image from a private registry from another company, which is obviously a very bad from their security perspective. And therefore, in this last release, what we saw that they added additional check that even the image is already present on the node and there is no need actually to pull that again. There is a revalidation of the credentials of the second pod to make sure that it has access to the same image.
Now, I'm very excited to talk about sidecar containers. Anyone who's familiar with my work will know it's been a question I've asked everyone I've spoken to over the last few years. And sidecar containers, of course, are in beta in 1.29. And I want to talk a little bit about this because our friend Matthias has been working on pushing that through to production readiness.
Yeah, so I think that most of us who are familiar with Kubernetes, heard about sidecar design pattern, and I think it's a very, very interesting thing, and it's been around, I think, from Craig maybe 10 years, maybe this whole idea, right?
Kubernetes is we're not quite at its 10th birthday, but as soon as there was a Kubernetes, people thought, how can I use this to deploy multiple things together as a pattern?
Yeah, and I think that this design pattern, like there are multiple solutions that are relying on this design pattern, and one of them is service mesh. But as it turns out, like sidecars weren't the first-class citizens in Kubernetes before. So they were like an injected container inside existing pods and workloads, and they didn't have their own name or own lifecycle management, and it caused multiple problems, stability problems, right? What just is the evolution come to a place where our friend Matthias and all the good people were in the Kubernetes maintainers were pushing for giving sidecar containers its own, their own right, and to be able to manage them with their own, properties and needs, and be able to, bring up not just bring up sidecars, before the main containers are starting, but also like having their own and priorities of turning them off at the end of the life cycle of a pod. So I think it's a very interesting thing. It's also like taps into the security spaces, since many sidecars have security purpose. So in general it will bring around more stability.
Great. Well, thank you very much for this little overview into what's new with Kubernetes security in 1.29.
Thank you very much.